Chapter 8. Code Component. The ultimate low-level DSP tool. DSP coding. For most tasks, SynthMaker's graphical programming approach meets your needs nicely. However, when it comes to programming DSP, a more algorithmic approach is required. For this purpose, we have the code component. Using the code component, you can do any kind of processing you like. The component uses a very small set of commands to allow you to translate DSP algorithms into very simple code. The code is then dynamically compiled into binary that runs extremely fast for maximum performance. The code component. You will find the code component in the code group of the toolbox. The component provides an area into which you can type your code. Click on the component to go into edit mode. You will stay in edit mode until you click or tab away. Inputs and outputs. In order to link the code into a schematic, you will need some inputs and outputs. The code component is used for audio signal processing, so it only allows you to create poly, mono, stream or stream boolean inputs and outputs. There are 8 commands for adding inputs and outputs. Poly, in, poly, out, mono, in, mono, out, stream, bool, in, stream, bool, out stream, in, stream, out. You need to make sure that you give each input and output a name, and that each line of code is terminated with a semicolon. Once the correct syntax has been applied, the input or output will appear automatically when you click or tab away. Stream Boolean inputs/outputs allow you to process or receive Boolean mask data. See the sections on expressions and conditional statements for more information on masks. The input/output names become variables that you can use in subsequent code. The variables will take whatever values come in or go out when you link the component to other parts of a schematic. If nothing is linked to an input, the variable will assume a value of 0. One final point worth noting is that it's a good idea to use stream in and stream out instead of the poly and mono alternatives, as your code can then be used in both poly and mono sections. Syntax coloring. The editor colors the code to indicate correct syntax. Input/output commands, operators and brackets are purple, variables are blue, and data types and functions are green. If at some point the syntax coloring stops and all text after that point turns black, this is an indication that there is an error in the syntax at that point. Editor. The code editor supports copy and paste through the standard shortcut keys, Ctrl+C, Ctrl+V. A local undo is also implemented to allow you to undo and redo typing, deletions, pastes, etc. The local undo applies to any changes you make during a particular session, between clicking in the component and clicking away. After that, you can still undo via the application's undo system, but this will only go back through changes made between edits. You can scroll using the mouse wheel or use the cursor keys. You can page using the page up and page down keys. Ctrl+Home will go to the top, and Ctrl+N will go to the bottom. Local variables. In addition to the data you draw from your schematic via inputs, you can also create local variables. These are defined in exactly the same way as the inputs and outputs. There is only one type of variable at the moment, and that's a float. This represents a floating point number. As with the inputs and outputs, you need to give the variable a name and terminate the command with a semicolon. Variables can be initialized at the same time as you declare them. You can write float x equals 3, and x will be assigned the value 3. Variables that are not initialized explicitly will be set to 0. You can declare multiple variables in a single line of code. For example, float x, y, z will create 3 variables x, y, and z. Assignments. Having set up your inputs, outputs and local variables, you can then move on to implementing your DSP algorithm. To assign a value to a variable or to send it to an output, use the equals operator equals. You can assign fixed values, or you can use a regular expression to calculate the value. The example opposite shows how you can combine all the elements discussed so far to create a simple mode filter. Expressions. Expressions can use a combination of mathematical operations and built-in functions. The following represents a complete summary of the operators and functions that are currently supported. Sin1, a mathematical sine, cosine and tangent. Cos1, a, the 1 indicates that the input value is converted to a value in the range 0-1 and not 0 and 2i. So 0.5 would be equivalent to I and 1.25 would be tan1, a, equivalent to I/2. Log 10, a, logarithm, base 10, of a. Max, a, b, the numerically largest, max, or smallest, min, of a and b. Min, a, b, rounds it to the nearest integer value above or below, so 1.4 becomes 1 but earned a, 1.6 becomes 2. Asterisk plus standard mathematical operations. Slash calculates the remainder after dividing the left-hand side by the percent right-hand side. Equals comparison operators. These generate a mask based on the result of the comparison. Equals and bitwise an operator. Use this to apply a mask. One limitation of the code component is that you can only have 8 successive operations in an expression. For example, the expression a equals 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 9 plus 10 is not allowed because there are 9 addition operations in a row. You can easily get around this by splitting the expression up into smaller sections using brackets, and, for example, a equals 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 9 plus 10. Conditional statements. Because SynthMaker uses SSE to process 4 channels at a time, conditional statements can't be implemented in the traditional way. However, you can achieve the effect of the conditional statement by using a mask. A mask can be applied to all 4 channels at the same time. Each channel is affected differently. SynthMaker includes conditional operators that generate exactly these kind of masks. For example, the following SynthMaker code. X equals X, X equals 1 and 1.0 is equivalent to the following C/C++ code. If X equals 1, X equals X 1.0. The equals operator creates a mask. The mask will effectively be true for each channel that meets the condition, and false for each one that doesn't. The bitwise AND will return a value of 1.0 or 0.0 for each SSE channel based on the mask. Comments. You can leave comments in your code. These are just snippets of text that remind you of what a particular part is doing. Comments take up no processing time. They can be put at the end of the line or they can have a whole line to themselves. For example, index equals index plus 1. // increment index // increment index equals index plus 1.